Hello everyone, this is our Fisher Sendo. Today I'm going to talk about the circular reference problem and its solution leak pointer. If you like this video, please click like and subscribe my channel as below so that my videos can be seen by others audience. And you also can find my complete video list in video description below. So this topic is followed up by my previous videos, which is the illustration for shell pointer. If you haven't got a chance to see that, please check the upper and the right bottom here. I will put a link here. So in these videos, I'm not going to build my own example since I saw an article from LearnCPP website. Um, these articles, examples, and illustration explain the whole topics very well. So I'm just going through this article with you and refer this article. So if you want to find the complete article, you can use keyword circular reference weak pointers at Google search. Then the first link pop out is the one of the complete article. So I talked about the limitation of shell pointer. One limitation usage is for when the circular reference happens. So what exactly of the circular reference? In this article, it expands these problems by giving an example. Please take 1 minute to go through the code. You can pause here. Okay, so here a person class has been defined. In the private variable, we also can see there is another shell pointer defined by class variables given the same class. Then there is a friend class function. This function is basically take two person shell pointer and assign each other's instance to its m_partner. So basically, this is a generally kind of circular relationship between two class instances. Then let's see what happens in the main function. First, it declares two class instance of a person, Lucky and Ricky, and then partner them together. When we finish this line, it's going to the destructor part. So following the destructor policy, Ricky will be deallocated first, then Lucy will be deallocated. However, this problem doesn't exactly as expected. From the terminal information, we can observe that the Lucy and the Ricky get created, each printing the construct function. Then Lucy and the Ricky is partnered up based on this function. However, we can see the destructor never been called for Lucy and Ricky. So what happens? So this paragraph explains these problems very well. It says at the end of May, the Ricky shell pointer go out of scope first, based on the destruction policy. Then when that happens, Rick will check if there are any other shell pointer that co-own the person Ricky. Because right now, Ricky is in the shell pointer. So the shell pointer basically check the last pointers which own the Ricky. So in this case, there are Lucy's partners. Since the Lucy partners has not been deallocated, so because of this, the system doesn't deallocate Ricky. If it did, the Lucy same partner will end up as Danker pointer, and it is sort of not follow the destruction implementation of shell pointers. At this point, we now have one shell pointer to Ricky, Lucy's partner, because that the Lucy's shell point declared here, the Ricky pointers declared here has been deallocated, but its partner, Lucy's partner, is still not deallocated. So this destructor will never be called, except the Lucy's partner has been deallocated, right? And we also have two shell point to Lucy's, the Rick's partner and the Lucy itself. So next, the Lucy shell pointer goes out scope. And same thing happens, right? So the shell pointer Lucy, check if there are any other shell pointers called the person Lucy. Because the Ricky's shell pointer still exists, so Ricky's partner still exists. So Lucy isn't deallocated as well. At this point, there will be shell pointer to one shell pointer to Lucy and one shell pointer to Ricky. Originally, we have two for Lucy, two for Ricky. So right now, we only have one to Lucy and one to Ricky. But the destructor will never be called anyway. So then the argument ends, and neither person Lucy or Ricky have never been deallocated. This is how it happens for circular references. Then, given a specific definition, here a circular reference is a series of reference where each object references the next, and the last object refers back to the first, causing a referential loop. The reference don't need to be actual C++ reference. They can be pointers, ID, or any other meaning of stuff. You can read more in the complete article for the explanation for circular references. So which means, so as we know, the shell point is built to avoid the memory leak, right? So here, if this happens, we also have the memory leak here. In this article, it's also given a reductive case, which means if you only have one class instance, it still can happen for circular references. In the example it's given here, like last examples, you have a class and it has shell pointer to for itself as well. Then if in the main function we assign its aim underscore pointers to itself, it will still lead to the circular reference. Because when point 1 goes out scope, it doesn't deallocate the resources because the resource pointer is sharing the resource. Then there's nobody left to delete the resource. Again, so we can see the resource has been acquired, but it's never been destroyed. I think this is a very brief example. If an interviewer asks you to give example of the circular references, if you remember this, you can directly write to the interviewer. I think this answer will meet their requirement. So how we resolve the circular reference problem, and this is how the weak pointers come to play. I'm not going to more details to explain the implementation of weak pointer in this video. In a nutshell, the weak pointers has two count, which is different than the shell pointer. Shell pointer has a one count to count how many pointers show this object, but weak pointer has two count. One count is count again how many objects show the data. Another count is explicitly say how many pointers are using this data. So if the user count going to 0, it will be make the big pointers can deallocate the data. Yeah, so here is the solution the author given to solve the first example. You just simply replace the shell pointer type of name pointer with weak pointer. Now we are able to see the Ricky and Lucy are all going destroyed. So basically what happened is when Ricky goes out of scope, you see there no other shell pointers pointing at Ricky. Because the weak pointers Lucy doesn't count. Because Lucy is not using that. then it will detect Ricky. Then same occur for Lucy. And further explanation given here. A weak pointer is an observer. You can observe and access the same object, but it's not the owner. So the key difference, please be careful that says observer is not the owner. So right now even the partner up together, but Ricky is only owner for Ricky, and also Ricky is only uh, observer of Lucy, but Lucy's on the Lucy's itself. Then this is how the solution for the circular reference. Um, However, weak pointer is not. It also has its own drawbacks. So the weak pointer is not like shell pointer, cannot be directly usable, and there's no operator like forward arrow. Uh, like shell pointers, you can link my videos to see how these operators forward implement. So to use a weak pointer, we need to convert to the shell pointer. Then you can use the shell pointers utilities functions. All right, so I hope my explanations explain these problems well. And for more details, you definitely want to check the original article. Uh, Thanks a lot. And if you have any further question and comments for this topic, please drop off your comments in below. See you in next video.